Hello, my name is George Lippos, and today we will be talking about the phenomena of a ball dropping. Now, you must be wondering why we, what's so special about a ball dropping, we do it all the time, we do it every day. Or, well, maybe not every day, but maybe when we were kids, we used to throw balls, catch them, toss them, watch them fly away, roll away. But what was really, really interesting about it is the physics behind it. The physics behind it. There's so many physics behind the ball dropping. So, for this experiment or project, I have a stress ball, which I will be dropping at a height just as tall, just as much as I can reach the ball as it comes down. And we will be calculating how long it takes to hit the ground. And with that, we have length or height, weight, gravity, acceleration, and time. So this video, I can't really show you the video, so here is me. Just as a little example, just a ball dropping, right? Or I can even, so with the ball dropping, from there we have gravity, which is 9.8. On top of that, we have the acceleration and the weight of the ball and the impact it does when it hits my hand. Especially if we do it this way, where I use my own force to lift the ball up. It will accelerate till it stops accelerating, then it will start accelerating downwards with, of course, gravity and everything. So just as a little example, because I can't show you the video at the moment, but that video will show you how I properly drop the ball, and yeah. Let's close this. Okay. So the reason why I wanted to do this is because, like I said earlier, we do this many, many times. We've done this many, many times as a kid, and a lot of people still do it many, many times as an adult. And, no one really thinks about, well, the physics behind it, right? You just think about throwing it and wherever your target is, right? But that's why I really want to do this assignment, because something so very simple is using a lot of physics behind it, which is extraordinary, Something so simple, yet a lot goes with it. So, with this experiment, we have multiple principles, right? We have the speed of the ball, the acceleration speed of the ball coming down. We have gravity. We have time, how long it takes from the second I release my hand down to the floor, and if it even bounces too. If it bounces, then it gets a little bit more airtime, and then until it reaches again. We have the length, so height, how tall I am, and mass, the weight of the ball. So equations, we have acceleration, velocity over time. We have speed, distance over time, gravity, which is 9.8. We have that. So yeah, so a little more in depth of the experiment. I am 6 feet tall, and if I lift my arm as high as I can, which is around 7'6", I timed the ball, and it took about 0.70 seconds for it to drop to the ground. The average weight of the stress ball is 4.8 ounces. Because I don't have a proper scale, so I just looked up online how much an average stress ball weighs. And with that, we have conversion of units. We need to find the acceleration, speed, and yeah. Thank you for listening to my presentation.